Welcome to Chapter 6 of Mobile Communications. This chapter covers Internet protocols. That means Layer 3, the IP networking layer, and Layer 4, mainly TCP and all its problems with mobile and wireless communications. Okay, so let's start with Layer 3, and most prominent on Layer 3 there's the mobility extension of IP, Mobile IP. So why having Mobile IP? Can't we simply use the classical Internet Protocol IP? Well, think of how the routing works. Routing in the Internet is based on the IP destination address. And the IP destination address consists of a network prefix and a host part, and the network prefix determines the physical subnet. So if you now move from one subnet into another one, so you change your physical subnet, this implies a change of the IP address. Otherwise, the address is not topologically correct anymore. So the point is, IP addresses, they have to be topologically correct. Otherwise, the internet will simply not work, or you need special routing entries in all the routers around the globe. Oh, that's a problem. Having specific route to end systems, so changing all the routing tables to forward packets, this does not scale. Think of frequent changes in location. Think of security issues. No way. Well, there's the other possibility, changing the IP address. So that means, depending on your current location, you will have different IP address. This is exactly what is done today. So as soon as you attach to another network, you will get, typically via DHCP, a new IP address, a topologically correct address. And this is fine as long as you download, for example, content from the network. So that means as long as you are a client connecting to a server, it simply does not matter what your IP address is. That means your IP address can change every 5 minutes, and as long as you act as a client, so what? But think of having a mobile server. How can you find a mobile server? It's impossible to find the mobile system. DNS updates, well, that takes too long time. Additionally, if you have a TCP connection, maybe you remember from basic networking classes, TCP connections defined by a socket pair, and in a socket you have your IP address. You cannot simply change the IP address. If you have a secured connection, well, you cannot change the IP address there because this is exactly a man-in-the-middle attack. So, you cannot change the IP address if you want to keep a connection, especially a secured connection. So, what do we need for mobile IP? First of all, I will cover Mobile IP version 4, and you see there are a lot of updates. The current RFC 5944 describes that it's very important to be transparent. Yeah, that's exactly what we want. We want to keep the IP address. And after interruption of our link, so we change from one network into another one, the communication should simply continue. So we change the layer 2 connectivity from wireless LAN to an LTE network, or between two completely different wireless LAN networks, not within a extended basic service set. No, changing from a public hotspot to your private network, for example, this should work. It should be fully compatible to all the existing layer 2 protocols, to all the higher layer applications and protocols, so we don't want to have any changes in the current end systems and the routers. Well, at least it should have some security, so we will see that we need some registration messages, and Mobile IP authenticates them. And what's quite important, it should be scalable, very efficient. So only few additional messages needed. So think of only, low data rates over the wireless link. We don't want to have this kind of inefficient exchange of many messages. So, what do we have? What is the architecture of mobile IP? First of all, well, some new acronyms, names. We have the mobile node. That's our host, layer 3, that can change the point of connection to the network. But this host doesn't want to change its IP address. Okay, that's your laptop, for example. Then we have two types of agents. A home agent, that's a system in your home network. Well, think of a router, for example. This home agent is important to register the location of your mobile node, and this home agent also tunnels IP datagrams to a so-called care-of address. I will explain it in a second. The other type of agent is a foreign agent. That's a system in the current foreign network. Also a router, for example, and this agent can forward tunnel diagrams to the mobile node. Quite common, this is the default router for the mobile node. Now, what is the care-of address? Well, that's, by definition, the address of the tunnel endpoint for the mobile node. This care-of address can be at the mobile node. This is called a co-located care-of address, or at the foreign agent. So from an IP point of view, this is the current location of the mobile node. And what does it mean? Think if you move, for example, as a student from your hometown to the town of your university, and right now you don't have an address, but you're just living at some friend's place. And for example, if someone wants to send a letter to you, well, maybe this person doesn't know anything from you now moving to another city, sending the letter to your parents. Okay, and what can the parents do? You're not officially whatever registered in this new town, but the parents could send the letter to a care-of address. Maybe the address of your friend, taking care of you, at least offering you a place to sleep. That's the care-of address. And then your friend at the care-of address will receive your letter, will see how this works in mobile IP, and can forward this letter to you. Finally, the correspondent node is any computer in the internet. So how does it work? Think of the example of you as a student moving to a new city. Think of the correspondent node simply wants to send you something, and you're the mobile node right now in a foreign network. Well, usually you're here somewhere. This is your home network. This is where your mobile node usually is. At home. Your university's network, the physical home network. So that's the network that fits to your address. And now you're somewhere else, but we don't want to change your address. But you cannot simply use your address because that's a topological wrong address. What happens now? Well, the correspondent node doesn't know anything from the fact that you're somewhere. The correspondent node will thus simply send the IP packets as usual. The home agent, that's your parents in the example with the letters, the home agents, they now intercept the packets, called a proxy ARP, and they intercept it, and they will answer also the ARP requests. Well, instead of your device, the home agents will answer. They will intercept the packets, and what they then do is they encapsulate all the packets. So, mobile IP creates a tunnel between the home agent and the foreign agent. Okay, a tunnel, this is nothing but encapsulated packets. That's your parents putting this letter of your friend in yet another envelope. Then data is forwarded via the tunnel until it reaches the tunnel endpoint. That's the care-of address. In this example, the care-of address is here at the foreign agent. The foreign agent decapsulates the packet, puts your letter out of the envelope, and then via layer 2 forwards the packet to your mobile node. And on layer 2 it doesn't matter that you have a wrong IP address. you still have your old IP address. But you will not notice that you're mobile because you will receive the packets and you can keep your address. So that's the basic idea of mobile IP. And for the way back, well, the mobile node simply sends its data. Well, and so what? Then, okay, the sender address is not topologically correct, but the receiver address will be, and then the internet forwards everything to the corresponding node. So nothing new here, and foreign agent then works as a default router. In the end, mobile IP creates something that is called triangular routing. The corresponding node does not know anything from the mobility, sends the packet with your normal IP address. The router, acting as a home agent, intercepts the packet, tunnels them to the care-of address, for example, at the foreign agent. The foreign agent forwards the data to the mobile node. And the way back, well, that's the normal way. So this is why this is called triangular routing of the data. This tunnel can end at the foreign agent with co-located care-of addresses. The tunnel will end here, but then the mobile node has to be able to handle these two addresses, the topological correct care-of address and its old address. No problem with Mobile IPv6, but a problem with the classical Mobile IP version 4. That's all about Mobile IP, so it's not that complicated. Some questions. What was the key motivation for the classical Mobile IP? Why do we need it? Why can't we use the normal IP in case of end system mobility? But, well, we are all using our systems. We do not have Mobile IP installed, at least we don't notice it. So why? How does it work? What is triangular routing? Now think of performance issue. What might be a problem?